Alright, so number 1 is in quad 2. The reference angle is 45. I got that from saying 180 minus 135. So this is quad 2, my x is negative. The sign is your y value. Number 2, 6 goes in 11 one time, 1 and 5, 6. So 1 means it's right here. I need 5, 6 more. It'd be either in quad 3 or quad 4. Which one? Quad 4, because it's almost another whole, isn't it? Okay, my reference angle is pi over 6. My ordered pair associated pi over 6 square root of 3 over 2, 1/2. Since this is in quad 4, my y will be negative, okay? But you want the tangent. What's the definition of tangent, guys? Y divided by x. So that divided by that, I take that, flip that division to multiplication, and I cancel the 2's. I get negative 1 over square root of 3. But I can't leave that square root of 3 there, can I? So I have to rationalize. So I get negative square root of 3 over 3. Number 3, cotangent of 45. That is 1. It's in quad 1, 45. Y, okay, tangent's y divided by x. Cotangent would be x divided by y. Number 4, sine of 2 pi over 3. That's quad 2. In quad 2, your x value is negative. You want the sine, that's the y value. Number 5, secant of 300. That is in quad 4. Reference angle 60. Ordered pair associated with 60 is 1/2 common square root of 3 over 2. So this is in quad 4. Y is negative. Secant is the reciprocal of your cosine. So I flip my 1/2 and I get 2. Are we good on that? Okay. But 4 minutes, and that seemed longer than what you... How many finish in 4 minutes? I just want to say that. Okay. Okay. So you got a feel for that. Okay. All right. Next thing we want to do, let's review for a minute. On your math workshop, that week 5 is due to when? Tomorrow. I didn't put that up there assignment because you've had several since last Thursday. You can do a little bit on your own. If you got that done, you can turn that in today. If not, it's tomorrow. Now, before, were there any problems, quadratic, that you had to do quadratic formula on week 5? How many? I'm going to tell you if you're correct. 2. There was 2 you got to do quadratic formula on. If you cannot factor it on Friday, on that test Friday, you got to do the quadratic formula. Is everybody clear with that? Okay. All right. So let's look at some review problems. What now? You just keep that trig thing. That was just for your learning experience. All right. Let's look at 2 problems here. Review. Because we have a math workshop test on Friday. That's 12 questions that you could have an easy chance to make 100 on. Number 1, what type is that? Quadratic. It is quadratic. I'm first see if it's set equal to 0, which it is. Alright. I'm going to try to factor it. Okay. You know I do mine. You might do yours. Do a little different. It's got to multiply to give you negative 5. Add to give you negative 4. That's negative 5. And positive 1. So I take a 5a out. That's going to give me a minus 1. I take a... Okay, that's it. All right. Now, let me know if it keeps going in and out. I think I fixed it. Okay, so now I have 5a plus 1 and a minus 1 equals 0. Set them both equal to 0. Some of us still have to show steps. That is fine. I really get the right answer. But if I move that 1 over, it's going to become a negative 1/5. A minus 1 equals 0. A equals 1. Now, number 2, what type of equation is this? It's a radical. Radical. I know this is a quadratic over here. And what family does the larger family does it belong to? Polynomial. Okay, this is radical. Is my radical by itself? You don't have these problems, guys. I made these up, okay? This is a radical. Okay, so I'm going to square both sides. That gives me 2k minus 3 equals k squared minus 6k plus 9. Okay, I went from a radical to what type of equation? Quadratic. So I'm going to get it set equal to 0. Move these two things over. It becomes a negative 2 and a positive 3. K squared, negative 6k and negative 2k gives me negative 8k. 9 and 3 gives me 12. It's got to multiply to give me positive 12, add to give me negative 8. That is negative 6 and negative 2. Set both of them equal to 0. I get 6 and 2. But do I need to check my answers? Yes. Okay, so let's take 6 first. 6 minus 3 is what? 3. So when I plug 6 in, I need to get 3, don't I? What's 2 times 6? Come on, a little stronger than that. 2 times 6? 12 minus 3 is? Square root of 9 is? Did it equal 3? Yes. Okay, 2. 2 minus 3 is? Well, right there. Is that radical going to equal a negative number? No, so your only answer is k equals 6. Does that make sense? Alright, so that's a little review for your test coming on Friday, your equation test, which we already had a test on in the math workshop. Now let's review what we learned so far for our next test. This is going to be on function part 2 test. That was part 1 test on function. The function unit is so big it takes about 6 weeks to do. So I give a test halfway and on the other half. So this is going to be the first thing on your next function, part B test. Determine if a function is continuous at a given point. So let's look at these problems here. I give you 3 problems and ask you, is it continuous? That means, is it defined? So here, what type of function is that? Rational. Come on, what is it? Okay. So x equals 1. I take this, I plug in 1 minus 1. Is this a uh-oh? Yes, you got to worry about that because we ran into some trouble. So is it continuous? No, it is not. Okay. Now, can I remove it? So what type is this? And that means, what's the current at x equals 1? Asymptote. Very good. All right, number 4. I take 2. Plug it in. 2 squared is? 4 minus 4 is? Did I run into some trouble? Yes. So is it continuous? No. Let's factor it to see what's going on. Which parentheses would x equal 2 be associated with? X plus 2 or x minus 2? Because if I set that equal to 0, it would give me 2, wouldn't it? Can I remove x minus 2? So what type of discontinuity? So that means what's occurring at that spot? A hole in the graph. Okay, 5. Put 3. 3 plus 1 is? Square root of 4 is? So I got an answer, didn't I? So is it continuous? And I will put f of 3 equals 2 because that is an answer. Are we good getting better at that?
Is that how we're going to do the problems?
Yes.
That's just saying yes.
Yes or no. And then write me, if it's no, what type of discontinuity? If it's yes, give me write it in that form right there. F of 3 equals what does it equal? Okay? Are we good on that? Okay? Okay, now let's get your homework out. This is your homework 1 through 4. Yesterday we talked about rate of change versus average rate of change and why we had to do average rate of change. Rate of change is only used for linear functions. That's known as slope because linear functions are constant. They have a constant ratio throughout. Average rate of change is when you've got to examine a part of the graph, like from this interval to this interval, and find the slope just between those two intervals. We have 4 of these, and I went ahead and worked these out so you can look at them. I know one is linear, so you should have got, what's the number in front of x? What's the slope in this, just looking at it? 3. Even though I asked you to do the average rate of change, isn't that a linear function? So you could have checked your answer and made sure it's 3 because the slope of that line is 3. Okay? So number 1 is 3. But look at number 2. Let's check 2 and 3. On 2, I got 11. So check your work there. This is on your quiz, like what I just reviewed, and this is on your quiz tomorrow, okay? Are there any questions on number 2? The interval is from 3 to 6. So x sub 2 is 6, x sub 1 is 3. Go right above it. F of 6, I had to find that. Go right above, had to find f of 3 and input those numbers. Number 3 is 6. Move this over so you can try to see both that work. So here's your answer. Number 3 is 6. Here's what f of 3 equals 2. F of 2 equals negative 4. Are there any questions on 1, 2, or 3? Or how I came up with a value? I can pinpoint if I know where you're having trouble. And finally, number 4 is negative 5. Your x sub 2 is 3 minus x sub 1 is negative 1. Your f of, well, g of 3. I should have g of 3, but it doesn't matter. Negative 31 goes here. And then g of negative 1 is negative 11. So negative 31 minus a negative 11, double negative, that becomes a positive, and you get negative 5. Since I got negative 5 there, what's happening to the graph in that interval? It's doing what? Decreasing. If you got a positive, it's what? Increasing. Okay? Are we good on those 4? Okay, I'm going to come around and look at your homework. Which one gets up? Number which one? Okay. Which part of number 3, hon? There's number 3, the 6. 6, 2, and negative 4. All that's number 3 right there. Thank you. All right. All right. Now, I want you to get your note out from yesterday. We didn't finish this on the average rate of change. We're going to start with number 7. That just reviews what we learned yesterday. Let's do that when we were clear. It says, consider the function this. What is the average rate of change between the interval x equals negative 2 and x equals 6? Okay? So let's set this up. A rock equals my x sub 2 is 6 minus x sub 1 is negative 2. I go right above the 6 and write f of 6 minus f of negative 2. This is on the paper from yesterday. Now, here's my function. Be careful with this function because this is where students make a mistake. You see that negative there? They include that when they square it, but actually draw that one in because you got to square the thing and then multiply it by negative 1, okay? That's where students make a mistake on that. Okay, so draw that in if you need to. So f of 6 equals negative 1 times 6 squared plus 4. 6 squared is 36 times 1 is negative 36 plus 4 equals negative 32. That's a double negative, so I just went ahead and put positive 2. That's how I got that. Now I'm going to plug in f of negative 2. Negative 1 times negative 2 squared plus 4. Negative 2 squared is 4 times negative 1 is negative 4 plus 4. Oh, I love a 0. They're so easy to work with. Yes. This is that same paper we did yesterday. The handout I told you the average rate of change is on the back of it. So I get negative 32 over 8, which is negative 4. Since I got a negative 4, what's happening to the graph between the interval negative 2 and 6 is what? Decreasing. Very good. Alright, what we're going to talk about today is position time graphs, and it's really, we're just dealing with average rate of change, okay? But you got to know this. You see these in science, especially physics. You see these in physics? Okay, let me zoom out just a little bit so you can see this whole graph. First thing I tell you to do, guys, is to read it and be able to understand what's going on in the graph, okay? So it says, shown is a position time graph of an ant moving along a wire. So let's stop there at the question right there. And we see this. So this is like its home port right here, its origin. The ant starts moving. What is represented on your x-axis? Time. Time is always independent, isn't it? You can't control time. Your y is the what? Position in millimeters. So this ant starts walking. When it goes this direction, is it walking away from you or towards you? Away on the wire. Then when it turns, it's walking what? Back towards you. This is back where? Away. And when it's just constant, that means what? The ant's not moving, okay? So does everybody see that? Alright, so it says, determine the time intervals the ant is moving away from the start. Okay, when it says determine the time intervals, or when is the ant moving away or moving towards you, you remember how we wrote increase and decrease in intervals? That's what you're doing with this. Your right intervals increase and decreasing, basically, okay? We only use the what coordinates? X. That's what you're doing here. So if I want to determine the time the ant is moving away, so it's from here to 4, isn't it? So I'm going to write 0 to 4, union. What's the next one? It's increasing from 5 to what? 8. That would be my intervals. That is moving away from the starting position. This won't be on your quiz tomorrow. This part won't. Now, this stuff, average rate of change will, but I'm not going to put one of these on the test tomorrow until we practice this a little bit every day. It says determine the time interval the ant is moving back toward the starting place. Well, there's only one time, isn't it? Between what seconds? 4 and 5. When is the ant not moving? From what? 8 to 10. Very good. We're not doing every one of these. Let's see here. D. Let's do D. It says determine the rate of change of the ant from 0 to 4 seconds. So A rock. The 0 to 4, is that your y values or your x values? X. So let's put 4 minus 0 on bottom. So on top it's going to be f of 4 minus f of 0. Now, we don't have no fancy equation to plug it into here. But do you have a graph where you could find the y values? That's what you would use here. If they give you a table or a graph, then you can just use that to find the y values, and you don't have to plug in an equation. But they don't give you that. You have to plug that in the equation, okay? So f of 4. If I go to 4, what's my y value? 16. What's my 0 value? 0. So that's going to be 16 minus 0, which is 16 over 4, which is equal to 4. That's my rate of change for that one. Yes, we do need to put the units. So what was on top? millimeters per what? Your seconds. You said, where did you get that? Right here and right here, guys. So distance was top, time was on bottom. So 4 millimeters per second.
So the Y value is pretty much the one on top.
Yes. Alright. Let's look at E. We're going to do one more like that. The rate of change from 5 to 10. So A rock, 10 minus 5, f of 10 minus f of 5. Okay, 10, the y value will be 12, minus the 5 is 4. So I get 8 over 5. Do not change that to a decimal. Remember, in slope, didn't we want that as a fraction? Because it was a rise over a run. So leave it. Don't make it a decimal, okay? So it's 8/5 millimeter per second. Alright, let's look at J and K, and we're going to call it a day on this stuff, okay? And we're going to move on to just understanding something else. It says, what is the maximum position the ant moves away from the starting point? What do you think? 16. That's the furthest distance is away, what? So your answer is 16 millimeters.
Can there be more than one maximum?
It could, but that it said, and that question said, what is the maximum? The furthest position. So that on that one, it's just the furthest. Okay. How many times is the ant 8 millimeters away? So we go find 8 millimeters right here. This is your Y, isn't it? How many times is it? 1, 2, 3. 3 times. Because of this line. 1, 2, 3. Are there any questions on those? I just think there's no sense in doing 4 average rate of change when we can just do 2, because you're going to get bored. Are there any questions on position time graphs? Okay, I'm going to tell you what your homework is before, but we're about to go on to something else. Your homework is only on average rate of change and one of these graphs, okay? What we're about to do is not in your homework tonight, okay? But I might run out of time and not tell you. You remember that homework sheet I gave you last night that's at the end of it? That just says homework sheet. I said put that somewhere. You're doing 1 through 10 on there. The first 7 is just looking at that graph, okay? Does everybody understand their homework? And study Greek quiz, that's your homework. Alright. Does anybody else need a homework sheet? Alright. Now, what we're going to do now is just see if we remember our parent functions. This is just labeling functions, okay? Try to this page. I think it's page 43 in your notebook. Page 43 in your notebook. Looks something like this. Okay, turn to page. I got you. Page 43. Turn to that. We're done off the homework sheet. You see, I got these graphs here. We're just going to make sure we know which one is which, okay? That's all we're doing the rest of the period. Now, you're going to have to draw and label these tomorrow in your quiz, so yes, you're going to have to go home and learn these now. These are in your quiz. All it is drawing and labeling. But we learned all these last year. Okay. The first one. A horizontal line is called a what? Type of function. Starts with C. I didn't know why I didn't finish writing the word out. Constant. That's a constant. That is constant. Oh, I'm sorry. I didn't go there. Blank is a group of functions that with graphs that display one or more similar characters. That's called a family of functions. Family of functions. And in the family, the simplest of the functions is called the parent function. I call that the mama function. That's the parent function. So family of functions, parent function. So a straight horizontal line is called a constant function. And in this case, it's y equals what? 4, because it's going through the 4, isn't it? So tomorrow I might give you y equals 2. You know to go to the y-axis, put a dot at 2, and draw a horizontal line. Do you see how that works? That's known as a what function? Constant. So what I would do tomorrow on your quiz is, let's say, y equals 2. You got to name it and draw it. You see how that works? Okay. This function is called the identity function. Identity function. Okay. And while we do this, I'm going to graph these things, so I'm going to show you how easy it is to graph them quickly, okay? I just like them graphed quickly. Okay, so tomorrow, let's say I have this graph for you. This is identity function. This is why it's called the identity function. Y equals x. If I plug 1 in for x, what is y? If I plug in 2, what is y? I plug in 0, what you get? If I plug in negative 1, I get. Do you see you get the same identity on both sides of the ordered pair? That's why it's called identity. It's a straight line. So tomorrow, all you got to do is graph me a few of them and draw a line. That's all you have to do to represent the identity. You see what I expect of you. You don't have to go through the whole graph all the way up to 9. Just plot me some and draw me that line. Show me that you know what that means. Okay? So that's the identity. Why did I put f of x and y? Because that's the what? That means the what? I just want you to know, either way, I could have an f of x or I could have a y. But that is the formula for the identity function. What's this one? What shape is that? Okay, so what type of function is that? Quadratic. And what is the equation for quadratic? The basic equation, x squared. Okay? You said, Ms. Chester, how detailed do you want us to go on that one tomorrow? I would just worry about 0, 1, and 2, and negative 1, negative 2. What's 0 squared? So I'm going to plot 0. What's 1 squared? What's negative 1 squared? 1. What's 2 squared? What's negative 2 squared? And you just drew the mama graph. I don't have to have 3 squared, 4 squared. Just pick me a couple and draw it, okay? That's quadratic. So I'm going to have y equals x squared. You're going to put quadratic. There's no word bank. I'm going to have y equals x squared. You're going to put quadratic and draw me the basic shape, okay? Okay. I messed up here. That's why I drew it up here. So that's the same graph, okay? I just didn't like that picture. All right. Next one. Cubic. That's the cubic function. It is just the simple mama is x cubed. That's the simplest of the equation. So f of x equals x cubed, y equals x cubed. So tomorrow I'm going to have y equals x cubed. You're going to write cubic and draw me the graph. On this one, all I usually worry about, what's 0 cubed? What's 1 cubed? Okay, what is negative 1 cubed? Negative 1. And I just do that. Because 2 cubed is 8. That's why you don't have to worry about all that, okay? As long as you got those 3 points. And the general shape of the graph. Okay? So this is what right here? This is the what graph? What is this? Cubic. What is this called? The what function? Identity. And what's a horizontal called? Constant. Okay. Now, this one's in the shape of a V. So what is that? Absolute value. You got to write absolute value. What we're going to be doing the next 2 days, you've got to know these. That's why we're just taking 15 minutes to make sure we remember these, okay? We're not going to do anything else with this today. We're just identifying and being able to draw them quickly, okay? Now, it is the absolute value, of x. That's the simplest of the equations. On this one, you could go on for days and days. What is the absolute value of 0? What's the absolute value of 1? Absolute value of 2? What's the absolute value of negative 1? Absolute value of negative 2? That's plenty. You just drew me the graph. Do you see that? I don't ask you to memorize a lot, but you got to go home and learn these tonight and be able to draw them. Practice drawing them on graph paper if you need to. Alright. This is known as the what function? Square root function. It is f of x equals square root of x. Now, let's think about this. If I had to draw this graph, you have input numbers in x. Could you put 0 in there? What's square root of 0? Okay. Could you put 1? Do you know the square root of 1? What's square root of 1? So I would go 1, 1. How about 2? Do you know the square root of 2? No. How about square root of 3? How about square root of 4? What's square root of 4? 2. I would plot those and draw the curve of it. Do you see that? Now, if you want to go all out and do square root of 9 is 3, that's fine. Okay? These are the two that you won't remember. So these other ones you should be able to review quickly. Now, these two I'm going to put... Now, I do put this one on the quiz. I don't put this one tomorrow, but it will be on the test. Okay? But let's talk about this. This is called the reciprocal function. The reciprocal function. R-E-C-I-P-R-O-C-A-L. Reciprocal function. And it is 1 over x is the formula, okay? So yeah, you're going to have to learn that one. What appears in this graph, guys? Asymptote. And it's at 0 because, can I put 0 in that equation? No. The only numbers I'll worry about on this one, guys, is 1. What's 1 divided by 1? 1. So what I'll do, watch this, to graph this, one divided by 1 is 1. 1 divided by 2 is a half. Just don't go past that and get as close as you can to that. Okay, what's 1 divided by negative 1? What's 1 divided by negative 2? A negative half. That's all you got to do for that function, okay? You see that? Make notes so you can remember how to study for this later. That is the reciprocal function. We use all these up to this point this year. Now, we don't use this much, but if you're going into college and economics, business, some math classes, you have to know what this function is. So basically, I just want you to be able to draw the parent function. We don't do anything else with this one and understand what it means, okay? This is called, it looks like a step ladder, don't it? This is called the greatest integer function. Greatest integer function. And do you see how its notation is an x with 2 brackets around it? That is the greatest integer function. Or sometimes you would see it with 2 brackets. A bracket or double 2 brackets. Either way, it means the greatest integer. So, we're going to take a moment to explain this to you. Like I said, we won't work with this one much, but I will explain it to you. Okay. So, the greatest, I drew it better up here so you can see it. The greatest integer, are there any questions on what you're expected to do on your quiz tomorrow on drawing those? Are y'all good? I need a hand signal. You understand what you need to go home and learn how to draw, okay? Alright, so the greatest integer function is, it says that it is equal to any integer less than or equal to that integer. So what do you mean? The greatest integer function says it is equal to any integer less than or equal to that integer. Okay, first of all, let's talk about what integers are. Aren't they just positive, negative, whole numbers? Integers do not include decimals or fractions, okay? The integer family. So if we look at this, like I said, sometimes you see double bar, that's why I put that up here. Negative 1.5. Remember, the definition was integer less than or equal to. What do you think the if I evaluated that right there, what would that be equal to? Negative 1.5. Remember definition, integer less than or equal to? Less than. So what's less than that? What is an integer that is less than negative 1.5? Negative 2 would be your answer for that. You see how it rounded down? That's what the greatest, an integer less than or equal to. So your answer there would be negative 2. Okay?
I'm still confused.
Okay, I just said you round down to the nearest less integer. Less integer. So if it's negative 1.5, what integer is less? Negative 1 or negative 2? Negative 2. Okay. You have the negative 4 in there. Negative 4. Is it an integer? Is negative 4 an integer? So your answer is negative 4. 1/3. Is 1/3 an integer? No, so that cannot be your answer. But you're going to round down to the less integer. What integer is less than 1/3? 0. Do you see that? Let's go back to it. I'm going to give you some, okay? Watch this. If I gave you the number negative 2.6, and I said evaluate, it's in greatest integer, negative 2.6. What is the integer less? Because negative 2.6 is not an integer, is it? What's less than negative 2.6 as an integer? Negative 3. If I gave you the number 5, is 5 an integer? So your answer would be 5. What if I gave you 2 3/4? 2 3/4. Is 2 3/4 an integer? Round it down. What is it? 2. Do you see how that works? You know how I do problems like this, but I'm going to put a bonus on your test so you just know. That's what greatest integer means. Does everybody understand? So this is why it explains the graph. Watch this. You see how I'm at 0, and it's a closed dot at 0? Because 0 is an integer. Okay, do you see how there's a line from here all the way over 1 and there's an open dot? That means all those numbers, all those fractions decimals that's on that rounds down to 0. Okay, I go up here. 1, 1. All the fraction decimals between 1 and 2 round down to 1, don't they?
Or so it's like 1.9 though.
1.9. Round it down. What is the integer? 1. So 1.9 is right here. That's why you see a solid dot all the way, solid line all the way to there, and it's a step ladder. So just start at that number like 1, 1. Draw it over here. Open dot. Come up. Solid dot over. That's how you draw that, okay?
So if it was negative 2.1, it'd be negative 3.
Yes. Yes. Because negative 3 is less than negative 2. The name is crazy because it says greatest, but it's actually, you're rounding it down to lowest. Does that make sense? We don't do anything else with that. I just want you to recognize this graph, be able to draw it, and explain the meaning, okay? Does that make sense? But you see how the graph is why it is what it is. Okay, so your quiz tomorrow is going to be on this learning target, finding the average rate of change. You got 2 questions like that, like your homework last time, and then 7 graphs you got to draw and label. This one is not on there, but that will be on your test when we get there, okay? Yes, yes, yes. This is continuity right here. And then your test on Friday will be 12 equations. But we're going to be taking these graphs, not this one. This is the only thing we do with that. You remember last year how you had to move it right, left, up, down, reflect, all that? That's what we're doing for the next 2 days. We're going to take it slow and do it for 2 days. And probably a little bit on Monday. And then my favorite thing comes next Monday and Tuesday. You remember graphing piecewise functions last year?
Yep.
Now, if you struggle with that in Algebra 2, it makes more sense in pre-cal. Okay? Because Algebra 2 is just total something new. Isn't that right, Parker? I explained greatest integer better this year, didn't I, Parker? I watched a couple YouTube videos to make sure how they explain it. Y'all have a great one. If you're having trouble with equations or trig, you need to come to 0 period. Let me work with you, okay? Yes, ma'am. 0 period. Yes. Thank you. do that. Nick, did y'all do greatest integer last year? Did you do greatest integer function last year?
Yeah.
Did it make more sense to each other? It's a weird function.
It always rounds down pretty
Unless it is an integer. Like -4 will be -4. If it's an integer. Probably look in the grade, it'll be good. You have that A document.
Weird. Hey, Esther.
Good morning. How you doing this morning?
Alright.
Good morning, good morning. Morning target. Homework position. Brendan, can you run an errand for me real quick? Before you get started on your work.
Yeah. I'm a lot.
Huh?
I'm a lot.
You have a lot, you said?
Yeah, I'm a lot. My legs hurt.
Go to these 4 classrooms right now. I can see 212 and ask them to come that to them. This classroom, these room numbers, just get those numbers right now. Okay? Thank you. Good morning. Good morning. These takes 35 minutes, 35 and 37. Here it is. It's 35 and 37.
Hey, Will, he did not add one for me. Oh, I'm not going to the game. I'll buy one from you next week. I'll go to that one. No, Jerry. I just don't want to buy one if I'm not going to the game.
Just a happy, but because I was going to switch it up a little bit.
I'm going to get this school by like 5.
All right, good morning.
Good morning.
We have a lot of learning today. It was a great first period. I know it's going to be a great second period. All right. Connor, math joke. Start us off.
You asked me too early. Like you don't give me time to go look.
Okay, I'm coming back to you. Mr. Hall, are you up? Mr. Hall?
No, sir, I'm not.
Isabella, get that homework back to that. Whose homework is that? Yeah, move that back to your notebook now. Mr. Hall, how many days do we have to register for the October?
23 days.
Thank you. And you will never do that again, will you?
No, sir.
And that's a warning to everybody. Don't you dare let me catch you copying homework. Okay, moving on. I'm over it. Now, store update.
20 to 19, but I think Mr. Will Vickers should have another star.
Yes, that's right. You did.
So it's 21 to 19.
Us?
We're ahead.
Did you give me mine last week?
For what, though? What did you do? Just remind me.
I'll check it.
When did you
That's
practice?
how I said Mr. Will Vickers.
I don't know. You checked it like Friday or Thursday.
No problem.
Or Wednesday. I don't know. I came in Wednesday.
Did you?
Yes, no, I got you up here. All right. That's right.
I have math club money.
Okay, that's going to be coming on.
But should I just turn that in next week?
Or if you think you're going to spend that time, hold on.
Well, I got a check, so it's fine.
Gotcha. All right.
You really on the math team?
Yeah. I told you I was gonna do it.
I'm
I don't go back on my word. Okay, no. I'm not like someone that said they were gonna go to the math meeting and not show up. Not adding anybody though.
I don't remember what I had.
If anybody still wants to be on the math team, we have spots.
I'm calling.
But our pre-cal team is pretty big. It's a good team. All right.
You're still recording, by the way.
Oh, God.
Oh, Lord.
47 minutes.
Ooh, that's